Hello, hello, hello. I don't know if we're recording or not, probably yes. Let me see. Yes, we're recording. So this is Alejandro. Just finished testing this beautiful P2P server. I'm gonna give you a walkthrough so you know what I'm doing. So first in my server side, I have some constants, have some headers. That's the way the protocol I did it. Have a class called server, which creates a server, get some information, socket ports, information about the files. And then you have basic API, load info, send, bind, listen, handle requests, handle data, show connections. This is a virtual method from the inherited people, and then close, of course. Then my main server, which inherits from server, has the handle data implemented. That's the virtual method that had to be implemented. And then has add a file, which adds the information of the file. It doesn't add the file itself, it just adds the information. You can see that it gets the info of the packets and the info of the size. And then you get an update file info, which updates the elements. And then you can send the file info to your P2Ps or your clients. And then they can download from other clients. That's pretty much what my server does. Yeah, it has a good amount of lines of code. Then I have a client. My client also inherits from server. The reason why it inherits from server because it has to have P2P capabilities, so you should be able to download from him too. But you don't ask him any data. You don't ask him any information about the packets. You just download the packets. I call them chunks. This is a get file chunk. This is how you get the file of the chunk. And then you have the handle file. And then you have get file info. Some of these APIs weren't fully implemented due to time, but everything is actually working for the P2P demonstration. Just I tried to go, more in depth, more 100%, and that's why I created some APIs. But then I realized that I was making this way too big, way too fancy, so I went back to the basics. But anyway, everything should be working. So get file chunks fully implemented, and then you add a file. Well, I'm gonna show you how to add the file, and then get file. Well, gets a chunk. It keeps getting chunks. And then I have my client, my project. Sorry, that's the client. My project. Let me just go a little bit down to show you how the project works. Well, my class is a class project one. It has a menu. It has some menu things that you can do, like change IP. This is in the starter. Obviously, it's not like ordered properly, but it's because of time constraints. Of course, I have the menu here, change IP, which is one of these guys here, number 8. And then I have my rest over here, which is create a client, close connections, blah, 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 blah. And then this is actually what executes. Now I'm going to tell you this code, this project was amazing because I get to do a lot of multi-threading. Basically, everything runs in a different thread. And yes, that's pretty much it. You can see if I just go start th. Let me see here real quick. Okay, so what runs in other threads are the clients. So like if you do a start new thread, you see there's a new thread for getting every chunk. And then you can in the server side, start new thread. There's threads everywhere. So 2 threads, 3 threads, plenty of threads. Well, it's actually just 2. So I have 2 threads for a server, 1 thread for a client, but because it's inside for loops, actually becomes several threads. And then I have my main thread that runs right here. Anyway, I'm gonna give the demonstration. So I want you to be looking at here, because this is where the magic is gonna come. So I have my menu. As soon as this gets connected, I have my server, my main server bound at this address, and then my menu appears. Good thing about this is that you can create several peers, Oh, I had a little mistake there. I should have given the give a port. Obviously, port number 1 doesn't get executed. So I'm gonna run this again. I'm gonna create a client, and then I want this to be handled by the OS. So I'm just gonna hit 0, and then let me put this up. So give a port, I hit 0, server bound and address blah. That's the server of the client. And then I can create more if you just keep hitting 1 and 0, 1 and 0. and then I can actually see the clients in number 2. These are all the clients with the IPs. Obviously the IP is to my computer, but you can change the IP with option number 8. So it's not only bounded, this simulation is not only bounded to this computer, but if you actually run it in a whole other server, you can actually create more clients. But anyway, clients should be able to talk to you, but it's just simulation purposes. Anyway, let's say I want to create another client and I'm going to use add file to client. So I'm behaving like my client. So I want to add a file to my client. So I just hit number 7. This will pop up. And then let me see, I'm going to add this file. This little bug, it's a macOS system because of the multi-threading that I'm throwing. It gives you just a warning, but it's not a problem. My program keeps running. And then, yeah, so I can see the files of my client by saying show client files. So that's number 6. I hit that there. I have the untiled.xcf, which is just the GIMP project. And then what I can do now is I can send that data with 9 add file info to server. So that will open this. Obviously this is like showing me that I'm in port 53079 right here, and I have these things. So it is the information which is persistent. That's why I'm storing some information. And then this file, so I will add that file. You see that because it's just the file info and my buffer size is 4000 bytes, you can send the file info in one send. So the client gets ACK from the server, which is always 8000, and then client receives N from server 8000, and that's pretty much it. Now I can actually hit 5, which is show server info, and then I have that. What a beauty, what a beauty. Anyway, so we have this 53079, and then I'm going to create a new client, and then I am going to give it port 0 because I don't want to find an open port. And then I have this, you're acting as client in port 53081. I can show you, let's do number 6, which is show things. So you can see there's nothing, and you actually, by now you can see that there's some folders created here. So this is actually my clients and their root directory, if you want to call it that way. And then what I want to do now, I want to show you download, and then I do the file name. I'm gonna put a wrong file name because I don't remember the name. It's just gonna not do anything. File not in the P2P network. You know, I have also handling control. That's why I want to do show server info one more time to actually see what's the file name, which is this guy. So I'm gonna copy that, and then I do number 4, what's your file name, boom, and then a lot of things happen. I'm gonna explain real quick what happened real quick. So if you see a lot of my, and this is all concurrent, that's why it goes so fast. I open a new thread for every chunk. Actually, I'm gonna walk you through the code so you can see more or less what I'm doing and how the randomity works to get the best of everything. So if answer is 4, that's the download, right? Current file, I get the file. If it's not, I get it. I just throw this and then we go back to the menu. If it is, I get my client, which is in my self.clients, the current port that I'm working with, and then I get the file info from the server address that will communicate with the server. This is the first thing that happens. So that will communicate with server. You see here, it's communicating with server 8000, and then it communicates with the actual person that has the file. Right now I only have one file added, but the good thing about this project is that you can create 1,000 clients. They will multi-thread, they will run, and you can actually prove all the capabilities of P2P in this simulation. This chunk priority calls get chunk priority and gets the info that you got from the server. Let's go get chunk priority. What chunk priority does, it goes through every element in the PAX info, the addresses, and then it adds all the packets of every address, and then it counts, you're gonna have repeated packets, obviously, maybe unique packages. At least you're gonna have one for every packet, and then you get the most common. This counter, what it does, it counts the number of repeated elements in a list, and then the most common, it will get you the most common element, and that's why later it's actually a list of two values. The first value is the element, and then the second value is the number of repeated elements that they found in this ls. So that's why here I make a small for loop and I just get the first element of this most common instead of just the number of repeated times. And then obviously I don't want to download the most common file, because that most common file, everybody has it. As Professor Wang Chao was explaining, you need to get the least packet, so your P2P can be productive. So that's why from most common you reverse it into least common, right? And then you return this. So that's happening in that get chunk priority. So then you loop for every chunk in chunk priority by priority, and then you get the file chunks, right? So once you get the file chunks, this gets multi-threaded in the client, and then you get your data, right? And then the file chunks are going to exist in a dictionary that has the file name and then the keys, which is each chunk. So you do for data in each chunk, and then you basically add this to a file name, and yeah, you open a file, you store the data, you close your file, and then obviously you have to update your data into the precious and very nice server. So add file info to server, you add that, and then you also become a seed of that file, right? This happens so fast, but I can show you show server info. We can do number 5, so you see that there's that too, 53081 now as part of the server seeders, if you want to call it that way. Before it was 53079. Obviously both of them are there. I just wanted to show you that, and that's pretty much it, what my program does. You can also see the clients. If you hit number 2, these are the current connected clients that are ready to seed. They are seeders. And yeah, I realized that you gotta randomize also who you talk to, because otherwise you're gonna be talking to only one person. So that's done in the, let me see, that's the other important thing that we gotta be careful. So it's in client get file chunks. So let's go to client. I want to show you that get file chunks. There you go. It's a thread. So here, what I'm doing here is that if all the address where this chunk was, I am getting the addresses, right? And then I shuffle them randomly. So I'm not gonna visit just the first person that had that file, because my dictionary is in order. I'm actually gonna just this shuffle is randomized, and then I can go from address in address. If you get the pack in that person, just get it. If not, that's fine, because it happens atomically. You just get atomically. I refer, there's multi-threading, so by the time you're getting chunk 32, you also got chunk 20 or chunk 1. That's why I have a dictionary that stores those chunks. And that's it. Then I put 10 to do, because probably I can expand this later. But as far as right now, I'm just gonna exit, and then you close all the ports safely, and then here persist. It's the persistence of the connection. Obviously, I change it to false, and then I close all my servers. Now let's check that you have here 1, and then you have here 2, so you successfully pass the thing, and you can pretty much go from there. I hope you enjoy my, I don't know how many minutes. Oh, 14 minutes. You better put this video in fast speed. And that's pretty much it. I spent a lot of time, I learned a lot through this project. First time I do that many sockets. I still have a lot of things to improve in my project if it will be fully deployed into something. But yeah, I learned a lot. That's the important thing, and I'm glad it's working. And I'm glad I was able to randomize and actually create a true P2P server doing my sockets, which are TCP/IP sockets. If you can see here, these are just TCP/IP sockets. And yeah, I implemented everything that was needed to do. Thank you so much for listening. I hope you have a great day and enjoy this video.